or afternoon or evening, whatever it is, Algebra 1 students. How'd you do? This test wasn't that bad. This test was one of the fair Common Core tests we've been given. So if hopefully you did pretty well, you should by now already have your score. So I'm guessing you're here, well, unless you're, of course, reviewing for next year. But if you already just took it, I guess you got your score already and you're looking to see what you got. Anyway, first I want to apologize. We're not sure my New York State decided to make us wait until June 30th to post these. Hopefully, the following year, us teachers can get together and tell them that was not smart and that was not good. I like getting these things out. I like getting these things out the next day, but I didn't. So this is going to be the video for, I don't know why that happened, part 1. Problems, I don't know what that is, 1 through 12. By the way, all of this stuff, if you're looking for the other parts, can be neatly found at www.nkinfinity.com. All right, and all of it, just go looking for, you just go on New York State teachers, New York State Regents exams, and they're all right there, all nicely organized. We also do the geometry exams. We don't have them all done, but we will have them all done eventually. All right, kids, let's get started with the party. All right, let's just get started. To keep track of his profits, the owner of a carnival booth decided to model his ticket sales on a graph. He found that his profits only declined, that means going down, when he sold between 10 and 40 tickets. Which graph could represent? So we're looking between 10 and 40. 10 and 40. That did not decline, that stayed constant. So that would not be the answer. 10 and 40. That looks like it's coming down between 10 and 40. So that looks like that might be the right answer. Between 10 and 40, that's going up. And between 10 and 40, that went up and then down. So obviously then answer choice 3 is the right answer. Not too difficult there. That was the whole first page. Problem 2. The formula for the surface area of a right rectangular prism. Us in the real world, I like to call us the real world people. We like to call this a box. This is a box. A right rectangular prism. Rectangle, right angles, and it's 3-dimensional. That means prism. That's what prism means. Is 2 length W's, 2 height W's, 2 length heights. Blah, blah, blah. Which term in this formula is not dependent on the height? Which term is not? All right, this is going to be like a vocabulary lesson. So, which term is not dependent on the height? So, area is equivalent to all of this stuff, which includes the height. So you're not going to be able to find the area without the height. So it's not area. That has height in it. That has height in it. I guess this would be it. I'm not really sure even what that question's asking. I would say that's the answer. Yes, that's definitely the answer. But I guess they're trying to figure out, let you know that area is in fact dependent on the height. These had the height in them. I'm not sure. I guess that term is dependent on the height because height's in it. Whatever. All right, so this is, do you know, 1, can you use your calculator, and 2, do you know what the square root function looks like? Well, the square root function looks like this. Now, if you come over to your graphing calculator, you could clearly see this by just hitting graph mode and doing the square root of x minus 2. And hit enter. It looks like that. It is a graph that moved 2 to the right because there's a plus 2 in there. Now I'm pretty sure that's an algebra topic, but these are just parabolas. These should have x squareds. This is just a straight line. I don't know why that came up. This is just a straight line. That's not going to work. This is the square root function right there. All right, let's keep moving. What question was that? That was question 3. So it looks like we got a dot plot or a scatter plot. Excuse me, a scatter plot. On a sleep study, sleep, I need sleep. Average number of hours of sleep per day, years and age. Wow. When you're young, it looks like you get a lot of hours. And when you're my age, my age is well over here somewhere, you don't get as much. But I don't really believe this because I get way more than that. The student used the equation y equals negative. Now it's negative because it's coming down, right? And it looks like, if we draw on a line of best fit, we should get here. Looks like, at 0, which would be around 0, we're getting about, what, 9 hours? All right. So this is our slope. Just kind of get you the idea what these things are. This is our Y-intercept. Now the Y-intercept represents the hours of sleep at birth, basically, at time equals 0, which really can't have time equals 0, but I guess it's that second when you just are born. What does the rate of change represent in terms of this data? Okay, so we're talking about the rate of change, which is going to be this slope. So basically, if you take a look at this, as we get older, the amount of sleep goes down. Well, because it's negative 0.09x, that means we're going to lose negative 0.09 hours every year. Year starts with Y, right? Year. Didn't say I could spell very well. Year. All right, so the average number of hours of sleep per day increases. Well, we're not increasing. That's kind of stupid. And so anything that says increases is just dumb. The average number of hours of sleep decreases 9 hours. Oh, that's all it is? Yeah, remember, this is how many hours they sleep when they're first born. And could you imagine decreasing 9.2 hours per sleep per year? I guess nobody sleeps anymore. That's just dumb. But anyway, it was designed to trick you. There it is, the answer. Lynn, Judy, and Ann were given this function. Now that it is a parabola, you should know it is a parabola because it has an x squared term. It is a parabola that's facing down because the leading coefficient is negative. Now if you don't know that, you can always graph it to make sure you know it. Oh, that's Jude, not Judy. And they were asked to find f of 3. Lynn's answer was 14. Jude's answer was 4. Ann's answer was plus or minus 4. Who is correct? That's interesting. Well, definitely not Ann. This is going to be a parabola that basically is just steep. And it goes like that. If you were to graph this on your calculator, it would pass to the point 32 up here. Now, it's definitely not Ann. So it's either going to be Lynn or Jude. And I'm going probably with Jude's answer. So I'm going with Jude only, 5. But I might be wrong. I might be Lynn. I don't even know. So let's check this out. Let's go over to our graphing calculator. That's not our graphing calculator. Let's go over to our graphing calculator. And we'll hit tab. We'll hit the up arrow. Hit the up arrow. Hit tab. Hit tab again. Hit the up arrow. We'll get rid of this crap. And we'll type in... I got to do this with my mouse. Negative 2x squared plus 32. Press enter. Now, in order to see this, you're going to have to change this number. So just double click on it and delete it and choose 50. Just so I can see it. Now, I knew I had to go to 50 because I had a y-intercept of 32. I'm going to go to my table. Actually, that's really all I need to be is, oops, escape, Control T. And I want to know what 3 is. 3 is 14. There it is right there. 3 is 14. Who had 14? Lynn. Lynn had 14. She's the bomb. Which expression can be used to... Okay, so now here's the trick. Are you kidding me? Why would they do this? All right, I have to tell you, I'm going to come back because I'm mad about this. So the reason I'm angry, a little bit angry about this, because we teach you guys over and over and over and over and over again that the first rule of factoring is to take out the GCF. Well, the GCF in this case would be 16, and you'd be left with t squared minus 4. And then you'd factor that to t plus 2, and t minus 2. So why in the world would they ever do a problem like this? It doesn't make any sense to me. This is the difference of two squares or the difference of perfect squares or whatever. So because they're both perfect squares, 16 is a perfect square, x to the 4th is a perfect square. Actually, this should be to the 4th. I forgot it was the 4th. And then these should be both squareds. But since this is a perfect square, what multiplies to give you this? 4t squared. What multiplies to give you 64? 8. So we're looking for the one that's 4t and 8, 4t and 8. That's this one. Why not using t? Gosh, I think I need some more coffee. 4x and 8, 4x and 8, 1's plus, 1's minus. There's the right answer. It's the difference of two squares. Now, why they had you do that and not... Man, I use t over here too. That is so embarrassing. Really ridiculous. Anyway, why they had you do that, I have no idea. You should have taken it with the GCF. Vinny collects population data, P of H, about a specific strain of bacteria over time in hours shown on the graph below. Which equation represents the graph of P of H? All right, so this looks like, could be exponential growth. I got to be able to plug in 0 and get 4. Now, that's really easy because if I plug in 0 here, I get 4. So that one works. If I plug in 0 here, I get 6/5, right? Because this goes away. So that's not right. If I plug in 0 here, that goes away, and I get 4.2. So that's not right. And if I plug in 0 here, this goes away, this goes away, this goes away, and I get 4. So it's either got to be choice 1 or choice 4. Well, now I'm going to plug in 1 and see if I get 8 out. So if I plug in 1 here, 2 to the 1 is 2, 2 times 4 is 8. So that does equal 8, but that doesn't mean that's the right answer. This one also could be equal to 8. We're not sure. So I'm going to grab my calculator, and honestly, I'm going to just graph both of them. So I'm going to clear this out. I'm going to graph both of these. So my first one that I'm going to graph is 4, 2 to the h. 4 parenthesis 2 parenthesis raised to the... You can't use h, you have to use x. Press enter. And I'm going to go look at the table. Control T. And I see 1, 8. Yep. 216. Wait, what are we looking for? 216. 332. That looks like that's the big winner right there. I'm going to guess that's the right winner right there. How do you know what number I'm on? What number am I on? 7? Yeah, and that's the winner. If you did that to this, let's go just do the other one real quick just to see. We'll get rid of this. And we're going back into graph mode. And we're going to do this. Control division 2 over 3 x. And then we got to do cubed. Minus x squared. Remember, you can't use h. Plus 3h plus 4. Plus 3x. I almost used h. Plus 4. Now, that does go through 0, 4. But if I go to the table, Control T. When I plug in 1, I don't get that. When I plug in 3, and there, so forth. So that's an easy way to check. I'm not sure the reason for that question. What is the solution to the following system of equations? Okay. Well, this one's easy to graph. I can graph this one pretty easy on my graphing calculator. This one, however, is not. What I'm going to do first is I'm going to divide it this side by 3 and this side by 3 just to get rid of that 3. So I get negative 2x plus y equals 4. We're going to bring the 2x over. So I get y equals 2x plus 4. Now, what I notice is that they are parallel lines with a different y-intercept. Well, if they are, now I know they're parallel because they have the same slope. So because they're parallel, what I'm going to find out is they have no solution. There is no chance that these things hit each other. But I could graph it on my calculator and show you 2x plus 8 tab 2x plus 4. You'll get two parallel lines, and they will never hit each other. And that's because they had the same slope. A mapping is shown in the diagram below. This mapping is a function. Let's see. See how February maps to two separate places? That makes it not a function. It's not a function, not a function. It's not a function because February has two outputs. I think that's right, because not a function because two inputs, January and March result. No, it's choice 3. A function is when your input maps to only one output. That would make it a function. And if you learned one-to-one function, which I'm not sure is in the Algebra 1 curriculum, it would have to be true about the other way as well. And then this would fail. This would make it fail to be a one-to-one function. But it already fails to even be a function, so it can't be a one-to-one function. So choice 9 is number 3. Number 9 is 3. Which polynomial function has roots at -3, 0, and 4? Well, because it has 0, I should be looking for an x on the outside. So these do not have an x on the outside, so these can't be an answer. Because this is a 0, I'm looking for a positive 3. And this is, I'm looking for a -4. So the choice answer number 10 is 3. That's really weird. Now, if you didn't know how to do it that way, again, I'm trying to show you a couple of different ways to do this problem. If you didn't know how to do it that way, what you could do, why do I keep doing that? What you could do is graph it. Graph it exactly as it appears. If you think this is your answer, and this is the one thing I suggest you always do on these problems, graph this. Okay, let's see if that's the right answer. We'll go x, parenthesis, x, I forgot if it's plus 3, parenthesis, x minus 4. And we should be looking for, okay, I think I forgot to put, I think I have to put a times here. All right, so what we're looking for is, does it have 0? Zeros are when it hits the x-axis. These are also called x-intercepts. Or they're called roots. They're called roots, zeros, or x-intercepts. Where does it hit the x-axis? Oh, it hits here at -3. Oh, it hits here at 0. Oh, it hits here at +4. And that's another way to solve that problem. Jordan works for a landscape company during his summer vacation. He is paid $12 per hour for mowing lawns and $14 per hour for planting gardens. He can work a maximum of 40 hours per week and would like to earn at least $250. So we're looking for something that's greater than or equal to $250. So this doesn't make any sense. If M represents the number of hours mowing and G represents the number of hours planting, so 12 M plus, why would, oh, planting gardens, and 14 G, we want that to be greater than or equal to 250. So I'm going to guess we can find at least 2 of those. All right, so that's all of these. These all say that. So, oh wait, here's a less than or equal to. That can't be it. That's less than or equal to. So it's got to be choice 1 or choice 4. Now, he can only work a maximum of 40 hours. Wait, where did it go? Right, maximum of 40 hours. So that means his mowing hours plus his gardening hours have to be less than or equal to 40 hours. And that's what we're looking for, and that's why it's choice 1. Anne invested $1,000 in an account with a 1.3% annual interest rate. She made no deposits or withdrawal in the account for 2 years. If interest was compounded annually, which equation? So all of them start with $1,000. Right? And if we're going to increase, increase our money, it's always plus. So we're looking for the plus. Now what we have to do, now the tricky part of this is we have to increase by 1.3%. To increase, that's a percent, 1.3%. To figure out what it is as a decimal, you have to divide that by 100. Or, if you were taught this, which is really cool, you really just move the decimal place once, twice. So you're looking for 0.013. And that's why the answer is choice 2. All right, let me just make sure I got the right answers. I didn't make any mistakes. I have the answers here. I don't have the solutions here. So 1 should be 3. 2 should be 2. 3 should be 4. 4 should be 2. 5 should be 1. 6 should be 3. 7 should be 1. 8 should be 1. 9 is 3, 10 is 3, and 11 is 1, and 12 is 2. All right, kids, that ends part 1, problems 1 through 12. How'd you do? Anybody get 12 out of 12? Those weren't bad. Remember, use your graphing tool, and use your brain, and use some algebra, and you should be able to figure them out. Okay, I'll be back in a few minutes to do the rest.